So the way bucket sorting works is you have an array of numbers. It can be integers or digits or whatever. And there will be 10 new arrays created going from 0 to 9. This is to symbolize the numbers that can show up in like the numbers originally in the original array. So each of these are buckets in a way. So it'll go from the least significant digit and then sort that into whatever. So say 45 will go to 5. So it'll do that for the first pass through this, and it'll go through every number, sort it by the least significant digit, and then move on. So moving on in a second pass, it'll go to the next least significant digit, which would be in the tens place. So for the first pass, we're just gonna have 45 be in 5, 78 will be in 8, 89 will be in 9, 21 in 1, and 41 in 1. So now we move on to the next place. So it'll now sort through these instead of the original array. So 21 will end up going to 2, 41 will go to 4, 45 will go to 4 after 41, 78 will go to 7, and 89 will go to 89. So putting it all together, you're going to end up having all these come down in the order that they were sorted. So it's going to be 21, 41, 45, 78, and 89. So this particular example only goes with 2 passes since there isn't anything in the hundreds place, but it will do that for each digit as big as the number will be. So the one drawback of this type of sorting would be the fact that if you have an array like this and say this is a whole new array that we have for another example, these are all just tens places and ones places. So if you add another number here that's say like 1,000, that's going to kind of mess with everything considering that it's way bigger than the rest of the numbers in the array.
So now more on to the bucket sort specs. So we have our average runtime, which will be O(n) plus k. This is also counting as our best runtime. Then we have our worst runtime, which would be O(n) to the second. The best data types for bucket sorting is integers, floats, anything that has to do with numbers. Worst data types would be string. I think it goes without saying, you wouldn't use booleans with the data sorting, or with bucket sorting in specific. And then worst data sets, it was kind of previously mentioned, but just to retouch on it. So let's say we are using integers or we are using floats. An array that would look bad is one that's consistently maybe 1 or 2 digits and then has 1 or maybe 2 that have maybe 4 or 5 digits. So let's say 5, 21, 1,000, and then 3. This 1,000 would cause it to run a lot longer than it needs to because it's going to be sorting for these 2 digits, and these have none in those spaces, so it's kind of pointless for it to be even running. Then we have, is the algorithm in place? So no, it is not in place. As Anthony showed you before, it shows external arrays that are used to sort. So you have your original 1, 2, 5, 21. And then you have these external arrays 1, 2, 3, 4, 5, 6, 7, 8, 9 that are used to sort before you can place it back into the array when it is sorted. Therefore, it is not in place. Now discussing if this algorithm is stable. Let's say we're given an array 43, 97, 42, 78, 15, and we have 97 again. So let's label this first 97A and the second 97B. Ideally, if the algorithm is stable, it'll end up with A and B in that order. So let's run it through and see if it happens. So we'll run through our least significant digits. So we have 43, we have 97, 42, 78, 15, and 97. We'll mark that one as A, and that one as B. Noting that we're going up in that order, it's still in the same order. Then we'll go on to our second round. Then we're gonna go 42, it's going to go into 4. Then we're gonna go into 43, 15, it's going to go into 1, 97, A is going to go to 9, 97B is going to go into 9, and then 78 is going to go into the 7. So everything is now in order. We're gonna get 15, 42, 43, 78, 97A, and 97B, meaning this algorithm is stable. Now, final note, note that this is going from least to most order. Fun fact, this is comparative to radix sorting. Radix sorting basically uses the same idea, same concept of going in this type of order. However, it is from greatest to least, not to be mixed up. And that is bucket sorting.